in our winter lecture series. It's our first in-person event in quite some time, I think 4 months, something of that nature. So again, very happy to see you here. And it's my distinct pleasure to welcome Johannes Preiser-Kapeller from the Austrian Academy of Sciences. And in a moment, I'll turn it over to my colleague, Bauke Vanderberg, to introduce him. Before I do that, I just wanted to say that we have several events coming up next week and in the coming weeks. On Tuesday, we have a research seminar lecture from our very own Karsten Wilke, In Search of Hebrew Epitaphs from Medieval Constantinople. And on Thursday, February 3rd, we have a lecture by Jeremy Walton called Houses of Worship, Objects of Heritage, on intersections of post-imperial memory and religion. So you're welcome to join us either online or hopefully in person. We're not sure how long the in-person events will last. This might be the last one of the semester. So make sure you don't miss the reception if you're here in person. Then I would love to invite Bauke Vanderberg to introduce our distinguished lecturer, Johannes Preiser-Kapeller. Thank you.
Thank you, Brett. And I will do it from here because, I mean, more people are online than here. So I'm sorry, guys. It's my pleasure to introduce Johannes, who received his PhD in Byzantine Studies. He's really, like I don't think you really need an introduction for everyone who is a Byzantinist, but I'll do it anyway, but not the Austrian way, but a brief kind of way. So Johannes received his PhD in Byzantine Studies from the University of Vienna in 2006 and has been a researcher at the Division of Byzantine Research of the Institute for Medieval Research at the Austrian Academy of Sciences since 2007, where he's the team leader of the research group Byzantine and Beyond. He's also an external lecturer in Byzantine Studies and Global History at the University of Vienna. His research focuses on many different things, including environmental and climate history and historical network and complexity studies. Among his long list of publications, the most recent include 2 monographs that are related to one another, entitled De Erste Ernte und der große Hunger, Klima, Pandemien und Wandel der alten Welt bis 500 nach Christus. And then the second part, Der lange Sommer und die kleine Eiszeit, about the period 500 to 1500. Both books deal with very relevant topics, climate, pandemics, and societies in ancient and medieval Afro-Eurasia. And I believe they're also related to the lecture of this evening, which has the title Signs of the End of Times, the Turn of the First Millennium AD, the Ord Minimum, and Natural Disasters in Byzantium and Beyond. We're very happy that you're here. Brett might have read the last update yet, but next 2 weeks, it seems we will be online. So this might be the first, for now, the last in-person event that we're doing. So we're very happy to have you. And the floor is yours.
Yeah. Thank you very much for the invitation, Brett, and thank you very much for the introduction, Bauke. It's a great pleasure and honor to be here, and especially also to be here live and in person, which is also a rare occasion for me now during the last 2 years. And I will start right away, and I hope I will give you some insights in what we can do on the basis of an collaboration between humanities and natural sciences. So as Bauke has mentioned, one basis of my lecture today are the 2 books I've published last year in spring, here with the publisher in Vienna. And the other basis for the lecture is 1 chapter to the forthcoming companion to the environmental history of Byzantium I'm co-editing with Adam Stevsky to be published with Brill maybe late this year or early next year. We will see. So I would like first to invite you to a tour across Afro-Eurasia to inspect some celestial signs and then also their possible physical backgrounds, what we now can say on the actual physical backgrounds to this portents on the basis of natural sciences. Along these lines, I would then like to introduce you to some climatic fluctuations in the late 10th and early 11th century, which are, among other things, connected to the so-called Ord solar minimum. But then I will also problematize this cooperation between the sciences and the humanities, especially with regard to using historiography of the Byzantine and other traditions just as data. And I would like to show that this will not work or does not work, although it's done has been done in several studies and is still done also in future and present studies. Before then I come to a conclusion and to contrast the ideal and the reality of this, what has been called the consilience of natural sciences and humanities with regard to the study of environmental and socio-political dynamics of the past. So first, a global tour to some of these portents of the turn of the first millennium. And I would like to start with the image which was included in the invitation to the lecture. As you have recognized, it comes from the famous Bayeux tapestry, and it shows one scene ahead of the Battle of Hastings, where some observers are seeing a star, a comet in the sky. And as we know now, also on the basis of calculations and historical astronomy, this was Halley's comet, who is returning to the environs of Earth on a regular basis. And this was again the case in April, May 1066. And it was visible across Western Europe, as you can see, but also in the Mediterranean and in Byzantium. And of course, the question was how to interpret this star. Was it a disaster in the traditional way, so a portent of maybe calamities to come, catastrophes to come? And of course, this very much depended also on the context of the observers, especially also then later ex eventu, after the Battle of Hastings, for instance. Of course, the star could be interpreted by the Normans as an auspicious sign, and by the Anglo-Saxons, the opposite could have been the case. In the Byzantine tradition, we have a reference to this star, which was Halley's comet, in the history of Michael Ataliates, and there it is embedded, and it is the peak of a long list of portents and calamities, and the star as such then is also interpreted as an omen, which then eventually has its fulfillment in the illness and death of the Byzantine Emperor Constantine X Ducas. And within this paragraph, we also have one common interpretation, which we also find in other sources, that these events were earned by our sins and were surely caused by divine anger. But it seems also that they were a predictive sign of the invasion by that nation. Of course, Ataliates is referring to the Seljuks, which I mentioned, and its destruction. For in divine science, and it's possible to glimpse not only the things that we have already spoken about, but also some things to come. So that's a framework of interpretation, which of course we also find in other texts and in other traditions. As we know now, Halley's comet is returning to the environs of planet Earth on average every 75 years. So we can also calculate and also identify earlier sightings of a comet with Halley's comet. And you see that's from the study of Thomas Wozniak. I will also refer to later, where you see we have various occasions. In the best cases, we have really observations across Afro-Eurasia, from Western Europe, over Egypt, the Middle East, all the way to East Asia. In some cases, only from one on these regions. This also depends on the atmospheric conditions at the time when the comet was around, and of course also on the base, depends on the transmission of sources. The last time the comet was visible before the year 1066 was in 989, and there again it was visible both in Western and Central Europe and also in Byzantium. And in Byzantium, it was in a similar kind, as in the case of Ataliates, embedded in a long list of portents and catastrophes in the history of Leo the Deacon, which, as you may well know, has a very strong apocalyptic tendency, also related to the year 1000, which was coming near, and Leo expected that this would also overlap with the actual beginning of the end of times, as we will see in the later paragraph. And again, this star is then interpreted as a bad omen, referring then to the big earthquake in Constantinople in October 989, which even damaged parts of Hagia Sophia, which was then even more than interpreted as a bad sign, of course, if the center, the sacral center of the city as such was damaged. And you see also the bareness of the earth and calamities that occurred all came to pass after the appearance of this star. Of course, the Byzantines were not aware that this was the same star, which they would also then see 75 years later again. Leo the Deacon is also referring to fiery pillars that were manifested in the north in the middle of the night. And not only this description, but also other descriptions remind of one phenomenon which we would now interpret as aurora borealis, northern lights, which were very rare at these southern latitudes. And we not only have descriptions from Central Europe during these years and from Byzantium, but also even from Egypt, so that far south. And the background to this had been unclear for a long time. Now it is connected to what has been called the 993-994 event. This was originally identified and defined on the basis of the identification of a peak in the concentrations of the isotopes of carbon-14 and beryllium in various sediments, including 3 rings, first in Japan and then in other parts of the planet. And as you can see here, this was really a global phenomenon. So this peak of carbon-14 and beryllium has been identified in various sites across the planet, as have been the similar peaks of these isotopes for the so-called 774-775 event, which was an event of the same kind of an even bigger magnitude. So what was the background to these phenomena, which also in the 8th century were connected to the sightings of northern lights, even in northern Iraq in the 8th century? So there is a natural cycle of carbon and also of carbon-14, but the peak of that scale can only be explained on the basis of the additional influx of high-energy particles from beyond planet Earth, either coming from the sun or maybe even from galactic phenomena such as a supernova explosion, whose radiation is then at a certain time arriving at planet Earth. There was a long debate which was the actual background to these events in the 8th and in the 10th century. Now it's fairly clear that it is connected to a peak in solar activity, and then in 993 to either an extremely strong flare, a solar eruption, as you see it on this modern day photograph of the sun, or even to a massive coronal mass ejection, which is exposing solar material millions of kilometers into space, and of course a showering of high energy particles then is arriving on our planet. Today, such a phenomenon would cause dramatic havoc, not only in the electronic infrastructure in the orbit, but also here down on the floor. So it would be a real catastrophe for our civilization. But of course, in the 10th century, there was no such electric infrastructure. So what observers at that time could see was the interaction of these particles with the Earth's magnetic field in the form of the northern lights, even at the southern latitudes. And this portents, Halley's Comet, and these northern lights were all embedded in this narrative of Leo the Deacon, who, as I've said, for the year 1000, expected the second coming, the Dept of the Savior of God, and the beginning of the end of times. So he was expected this. He didn't live to see this. He maybe died before or in the year 1000, but this is the framing of his entire narrative, which is especially focused on the first half of the reign of Basil II, and we will return to this later. But as I've said, this was not the only time in the 11th century where we have such an apocalyptic expectations. Also later dates with reference to various calculations were connected to possible starts of the end of times, of the apocalypses. And we see this in the Armenian tradition, in the history of Matthew of Edessa. Matthew of Edessa is writing in the 12th century, but he has long passages referring to the prophecies of one of the main interpreters of the scripture in the 11th century Armenia, which was Johannes Preiser, or Johannes of Taron, as he is also called. And the first is dated by Matthew to the year 1029-30, although he's also referring that still Emperor Basil II was ruling, although he had died in 1025 already. So the dating is not quite clear in this regard. And therefore, it's also a little bit complex with which actual astronomical phenomena we can connect these descriptions, but he's referring to the solar eclipse, other celestial phenomena, and these motivate the king of Armenia to consult Johannes Preiser, and Johannes then is interpreting this connected to the 1000th anniversary of the baptism of Christ in the river of Jordan, and he also says that this marked the binding of Satan and Satan is now 1,000 years later set free again in order to fulfill his role, which he has to do in the Apocalypse, as we know from the last book of the New Testament. So this is another point in time, and we have similar calculations also in Western Europe with regard to around the year 1030. So as I said, it's not clear which phenomena then actually form the background to this interpretation. We know that in August 1030 there was both a lunar eclipse and a solar eclipse, which were partially visible in Armenia. Especially spectacular, and we also have descriptions from Western Europe, was an annular solar eclipse in June 1033, where you see it was very much visible in Western Europe and also across Armenia. So the red line, this is the core of the eclipse, which also covered Armenia at the time. A few years later, another portent occurred near Easter in the year 1036 or 37. A solar eclipse occurred, and again, Johannes Preiser is consulted, and he is explaining this. Yes, this is 1,000 years since the year of the crucifixion, and as the crucifixion was accompanied by a solar eclipse, of course, this also happens now, because the circle of time is coming to its fulfillment, and we have the same phenomena as it was at the time when Jesus Christ died on the cross. And again, actually, we know there was a solar eclipse 2 days after Easter Sunday of the year 1037, visible especially in the north of Europe, but also partially visible in Armenia, and obviously sufficient to cause also some of these concerns. So we see we have a variety of interpretations at various points in time across the Christian historiographies from Western Europe via Byzantium down to Armenia. But we also have similar or apocalyptic expectations of another kind in the Islamic tradition, for instance, within the Ismailiyah movement, part of the Shia, where there was the expectation of a revelation of the Mahdi, of the Messiah-like figure, one could say. And this, for the Ismailiyah, then was manifested in the revelation of the first Mahdi and Caliph of the Fatimids in North Africa, from where then the Fatimids in 969 also conquered Egypt. And especially in the early Fatimid historiography, we have various references to such expectations, also to portents, to celestial signs, which are interpreted as signs, auspicious signs also with the connection of the return of the Mahdi in the form of the Fatimids. However, such signs could also be connected to events which were directed against the Fatimid regime, such as a rebellion in modern-day Libya, which took place in the year 1005-1006, led by a certain Abu Raqqa, who claimed to be a descendant of the Umayyads, who at that time were ruling in Al-Andalus. And this was connected with a very rare phenomenon, the visibility of a new bright star, a nova in Latin, or even a supernova. We know now that it is not a new star, but actually the death of a star which is behind this, but this was the earlier interpretation. And this supernova, as we know now, is described in Egyptian texts, such as by the eyewitness Ali ibn Rigwan, a physician active then especially in Fatimid Cairo. But we also find such descriptions in the annals of the monastery of St. Gallen in Switzerland, and we have similar descriptions across Afro-Eurasia, as we will see. We now know that behind this was a supernova which took place, or which was visible. It took place much earlier, but which was visible on Earth in April, May 1006. And to the left, we have a reconstruction how it must have looked in the southern sky. So it was really the brightest star visible at night. And we now know that this was visible in the constellation of Lupus. And the remains of the supernova of these exploding stars have been identified within this nebula NGC 5882 at a distance of more than 7,000 light years. These are the actual remains of the supernova photographs with Hubble, with the Hubble telescope. And this supernova was really visible across Afro-Eurasia. So we have references to Western Europe, across the Middle East, all the way to East Asia. And we also see again how such a phenomenon could cause some insecurity with regard to its interpretation. The Song emperors in China had state-sponsored astrologers, but the first were not sure, was this an auspicious sign, was it a bad omen? Until then, one of these astronomers, Shu Keimin, makes clear it is an auspicious star, and the emperor, of course, is happy about this and then gives him a promotion, which was beneficial for both sides, of course, because it was supporting the legitimation of the emperor. Maybe another supernova you have heard about, which is even more famous, at least in the popular imagination, is the one of 1054, visible in the constellation of Taurus. And again, you have a reconstruction of how this must have looked like. We now assume that the remains of the supernova can be found in the Grab Nebula, which you see to the right. And again, it was visible in East Asia, but also, for instance, in Fatima, Egypt. And this supernova fell in Japan within a time which was filled with apocalyptic expectations on the basis of another tradition of Buddhist expectations. Also, Buddhism is a tradition that there would be 3 ages of the Dharma, and the last one in Japanese Mappo is the degenerate age of the Dharma, where not only Buddhist teaching would be in decline, but also society as such would get into crisis, filled with portents, catastrophes, warfare, also a decline of morals. And there were various bases how to calculate where we should expect the beginning of Mappo. And one interpretation was to expect it 500 years after the official introduction of Buddhism to Japan, which would have been in the year 1052. So we have various references at that time and also in later writings that this was the beginning of Mappo. And again, it was connected to some of these portents, such as the supernova, but also with catastrophes down on Earth. So very real manifestations of calamities, such as a devastating fire of the Buddhist Hasidera temple in the older capital of Nara in the same year of 1052, and also to a sequence of very cold springs, which characterized the climatic condition in Japan in the late 10th and early 11th century. And we can reconstruct this on the basis of the registration of the beginning of cherry blossom in the then capital of Kyoto. And these registrations start in the late 9th century, so they allow us for 1,200 years to reconstruct spring temperatures in Japan. And as you can see here, in the late 10th and early 11th century, there were particularly cold conditions, which of course also had impact on crop yields and on agricultural economy. And we will see this is, again, also a global phenomenon. We have the same similar climatic fluctuations across Afro-Eurasia at the time. And of course, as we have seen in the beginning in the text of Ataliates and also in other texts, there is this notion that these portents, meteora, everything which is in the sky in the ancient Greek tradition, this not only includes what we today understand as meteorology, the weather, but also everything, also other celestial phenomena, that there's a connection to what is going on down on Earth. So that these portents have a relation to actual calamities, catastrophes, dynamics showing up on our planet. And this is roughly, this is a framework of interpretation which we find across these cultures. And one could say it actually finds then confirmation, because then in the 11th century, we also have an increase in the frequency of climatic calamities. For the Western Latin tradition, Thomas Wozniak in 2020 has published this great and massive systematic work with catalogs of all these events. You see here a list of celestial phenomena which have been connected to the death of kings from the 6th to the 11th century. And you see many of these prominent figures have been then connected to such celestial portents. And Wozniak also provides this very interesting graph, what kind of phenomena we have to reckon with. On the one hand, astronomical phenomena, which could take place within our solar system, such as these solar eruptions in 993, but also events far beyond our solar system, such as the supernovae we have discussed. And of course, then we have the phenomena within our atmosphere, from the highest layers with the northern lights, aurora borealis, but of course, especially interesting for us are the phenomena in the lower layers of the atmosphere, which actually have an impact. So aurora borealis or supernova, that's interpretation, but the direct physical impact down on Earth we have for these lower layers with regard to climatic weather phenomena, sometimes also connected to volcanic eruptions, as we will see. And this leads me to the second part of my talk about these climatic fluctuations, which we can observe in the early 11th century. And this runs counter to some popular narrative, which you still find also in school books or also in other publications about this period of the High Middle Ages between the 10th and the 13th century, which is often subsumed under the term of the medieval warm period, or even medieval optimum. So the idea that it was a constantly beneficial climatic period which allowed for the growth of Europe with regard to demography, economics. For instance, that the Vikings were able to settle on Greenland. And this is often also used as argument by deniers of anthropogenic modern-day climate change. They argue already there was global warming in earlier periods, humans had nothing to do with it, and it was even beneficial for human society. So we should not have any problems with modern-day global warming. And of course, yes, there are some signs of demographic and economic growth in Western Europe and in other parts of the ancient world, starting from the 10th, 11th century onwards, like the increase in the number of cities. And some of this is supported for sometimes for periods of increased stability of climate. But at the same time, as we will see, there is nothing like a coherent medieval warm period. Even within this period, there are periods of higher climatic instability, such as the 11th century, such as later periods. And at the same time, there is no automatic correlation between these medieval climate anomalies, as it is now called, and more beneficial or stable social conditions. And even this economic and demographic growth as such, which can also be observed in Song China, and the Northern Song dynasty has even been called the first industrial revolution, also had some implications for the stability or the vulnerability of the societies to later periods of climate instability. What we can learn, for instance, from the case of Northern China at this time is that the increased use of the landscapes along the Yellow River, the demographic growth, led to an increase of the sediment burden of the Yellow River, led to an increase of the risk of erosion and large-scale floodings, which then manifested itself in the 11th century with the increasing frequency of calamities like extreme rainfalls, which then led to some of the most catastrophic floodings along the Yellow River. So this earlier period of growth brought about an increase of the vulnerability, an increase of the risk for the societies. And this also has to be taken into consideration if we talk about a medieval climate optimum as being a period of universal stability. This was simply not the case. And the background to these climatic fluctuations in the 11th century is at that time not man-made. These are natural fluctuations, such as fluctuations in the activity of the sun. These are minor fluctuations with regard to the entire amount of energy within the sun, but still they have significant impacts on the amount of solar energy arriving on our planet. And the scale of solar activity can be connected to the number of sunspots. The more sunspots you can observe, the higher is the activity of the sun. And the other way around, if you have few sunspots or no observations of sunspots at all, and we have systematic observations of sunspots going back in Song China to the 11th century, this is an indication of the reduction of solar activity, a reduction of the amount of energy arriving on our planet, and this minimized, they are called, often overlap with periods of, on average, lower temperature, especially on the northern hemisphere. And such a minimum has been reconstructed for the period between 1010, 1020, and 1080, named after the Dutch astronomer Oort. And this was really a global phenomenon. So we have not only a reconstruction on the basis of natural scientific data, we have an increase in the amount of calamities and climate extremes, as we would call them today, in various historiographies, in Western Europe, in Byzantium, in the Middle East, in Central Asia, and in East Asia. And we will inspect some of these descriptions. At the same time, these fluctuations in the solar activity then also had an impact in the manifestations of the major climatic oscillations, which are determining the weather phenomena in the Eastern Mediterranean. And I've tried to put this on a map, and you see also the Byzantine Empire in its glory of the 11th century. And one of the most prominent of these oscillations is the NAO, the North Atlantic Oscillation, which is defined as the difference between the pressure systems in the Mid-Atlantic and the North Atlantic over Iceland. And this North Atlantic Oscillation has normally two main manifestations. a positive one, where these two pressure systems are very strong. And this usually causes warmer and wetter weather than normal in Central and Western Europe, but drier conditions in the Mediterranean. And on the opposite manifestation, when these pressure systems are relatively weak, we have cooler and drier conditions, especially also cooler winters, but also cooler summers in Western and Central Europe, but wetter than normal conditions in the Mediterranean. And throughout the most stable periods of the medieval climate anomaly, the NAO had normally a positive manifestation. So therefore, we have more beneficial conditions on average in Western and Central Europe. Whereas in the succeeding Little Ice Age, the opposite was the case. And this was also the case during more unstable periods like the odd minimum. So also during the odd minimum, there was more of a negative NAO mode and therefore often cooler and less beneficial conditions in Central and Western Europe, but sometimes more wetter conditions in the Mediterranean. However, the weather in the Eastern Mediterranean, in contrast to the Western Mediterranean, was also influenced by another pattern, the North Sea Caspian pattern, which is defined as the difference between the pressure systems over the North Sea and the Caspian and in the inner Asia. And especially during winter months, this North Sea Caspian pattern can contribute to an inflow of more humid air masses from inner Asia and from Siberia, especially also in connection with the Siberian High. So we have then more than normal precipitations in the Eastern Mediterranean, but also can contribute to the inflow of very cold air masses from inner Eurasia and from Siberia, and extreme cold. And this can actually be observed in the 11th century, when we have descriptions that the river Tigris was totally frozen around Baghdad, for instance, or that there was snowfall near the pyramids. And that this is possible, we have seen in the last days. So when even on Amorgos you have snowfall, that's a rare phenomenon. But in the 11th century, this happened quite frequently on the basis of this interaction between these various climatic oscillations I have talked about. And finally, especially important for the Nile flood are the monsoon systems across the Indian Ocean, which contribute to the precipitation in the regions of origin of the Nile, especially in East Asia. And this monsoon system, in turn, are correlated with one of the biggest climatic oscillations, the so-called Enzo El Nino Southern Oscillation. This is defined as a difference between surface temperatures in the oceans around modern-day Indonesia and offshore northern South America. And there has been observed since the 1950s that often around Christmas, and hence the name El Nino, there is a reversal of these temperature conditions. And this El Nino phenomenon that has massive impact not only on precipitation conditions around the Pacific, as you can see, but also all the way to Central Asia and East Africa, for instance, contributing to fewer precipitation in the regions of origin of the Nile in Ethiopia. And we have various sequences of very low Nile floods, for instance, in the 1060s, which can be connected to such El Nino phenomena, which also can be reconstructed on the basis of proxy data from South America. And the opposite manifestation of the Enzo would be La Nina, where you have then opposite phenomena. So then it gets very wet in the regions which are dry during El Nino manifestations and the other way around. And again, you see this is covering large parts of the old and the new world. Besides these long-term fluctuations, there are also short-term fluctuations for 2-3 years, often connected to major volcanic eruptions. So major volcanic eruptions, we have just experienced this spectacular one in Tonga in the Pacific, which, however, is, as far as we can reconstruct now, has a rather modest contribution to climatic changes. But major volcanic eruptions have major impact on the composition of the atmosphere. A huge amount, often millions of tons of aerosols are ejected in the upper layers of the atmosphere, like after the eruption of Pinatubo in modern-day Philippines in the 1990s, and they can contribute to a decline of solar irradiation, which makes it down to the surface of the planet. So on average, they can contribute to a cooling, to lower temperatures, like in the year without summer after the eruption of Tambora in 1850, and the year without summer in 1816. However, recent studies also show that these climatic anomalies, depending on the seasonality, on the amount of aerosols, and also on the airflow system, can also contribute to other phenomena, such as droughts or other climatic extremes. So in general, they can contribute to more turbulences in the climatic system. And this is a reconstruction of major volcanic eruptions in the last 2,000 years. This was created on the basis of ice cores from Greenland. The Greenland ice is one of the most important climate archives because it preserves earlier snowfall of thousands and hundreds of years ago. And this earlier snowfall, these layers in the ice, preserve the chemical composition of this precipitation at that time. And after volcanic eruptions, you have an increase of certain chemicals, such as sulfates, which then indicated a major volcanic eruption took place. And sometimes it's possible also on the basis of written evidence then to connect this with a specific volcanic eruption. And two major volcanic eruptions took place in the mid-10th century, one connected to the volcano Elka in Iceland in 939, and another one in the year 946, the volcano of Chiang in modern-day border region between North Korea and China. Maybe you have seen the Amazon science fiction movie, The Tomorrow War. I don't know if you have seen it. In this movie, there's a reference into this volcanic eruption, and it helps them to defeat some aliens, which otherwise is very rare for paleoclimatologists to be so helpful. These ice cores in Greenland, I'm on what Christian Pfister, one of the Swiss pioneers, the Swiss pioneer of historical climatology, has called the archives of nature. So these are natural phenomena whose composition, whose quantitative composition, or whose chemical composition in time depends on climatic factors, precipitation, temperature, and in turn, these phenomena then can be used to reconstruct earlier precipitation or temperature conditions for periods where we don't have any systematic instrumental measurements, which for most parts of the planet is everything before the 19th, 20th century. And you see here two maps. One, these are proxy sites, various types of proxies, and the sites for the Eastern Mediterranean, and the other for East Asia. And you see there is a significant amount of such proxies, and it's growing every year, one could say. But you also see there's a high spatial inequality with regard to its distribution. So we have areas where we have a lot of these proxies, and other areas are not covered to the same extent, which of course makes them overarching reconstructions rather complicated. One of these archives of nature, which is, I think, also easy to understand its mechanisms, are tree rings. Of course, the strength of a tree ring depends on the growing conditions in the specific year, temperature, precipitation, and it can be used to reconstruct these earlier conditions. The longest tree ring series we have now for Central Europe goes back 12,000 years until the end of the last ice age. And you see also a reconstruction of temperature conditions in late medieval Austria on the basis especially of tree rings from the Alps. The counterpart would be archives of society. So these are mainly written sources, either occasional observations, especially of climatic extremes, droughts, floods, or systematic observations. In the best cases, maybe even measurements of some phenomena. And Christian Pfister has also published recently this book, Climate and Society in Europe, which I can recommend because it's really a handbook of this methodology. And such examples where we have long-term written sources really of quantitative measurements. One example are the Nile floods. The Nile floods at the altitude of these Nile floods has been registered in Egypt since antiquity, and we have a continuous time series starting in the year 622, which really allows for long-term reconstructions, especially also of precipitation conditions in East Africa. And the other example I've already mentioned are these registrations of the spring, the beginning of the cherry blossom in the spring in Kyoto in Japan. And just to mention it, the spring in last year, the cherry blossom in last year was the earliest in the last 1,200 years, which also is a manifestation, I would say, of modern day climate change. And as I've said, especially in the late 10th and in the early 11th century, we have often clusters where there are low, insufficient Nile floods for several years in a row, up to 6-7 years. So, like in the biblical story of Joseph and the 7 cows and the vision of the Pharaoh, this actually happened and contributed really to major crises already in Egypt and then also in Fatima, Egypt in that period. And we can connect some of these sequences of low Nile floods, as I have said, with El Nino manifestations also reconstructed from other proxy data from the Pacific. So of course that's ideal material, but there are also attempts to turn qualitative data, so say normal historiography, into quantitative data. Christian Pfister has developed here an index system. The basis are various overlapping descriptions of weather phenomena for the same period, for the same region. So we of course developed this for late medieval and early modern Western Europe, where you actually have such a density for some places. From the 16th century onwards, you even have systematic weather diaries. And if you, for instance, have in various of the sources the description in the winter of 1453, the Danube was frozen for 4 weeks in Vienna, and we have various overlapping descriptions, then you can make a categorization in this index between, for instance, extremely cold or extremely warm winter. So these are normally categorizations for entire seasons. And then such a time series is created, and then when there's an overlap with periods of instrumental measurements, the attempt is then to reconstruct, to calculate back earlier conditions, so average winter temperatures or average summer precipitation, for instance, whatever is possible on the basis of the density of evidence. And as I've said, this works quite well for areas and periods where you have a high amount of evidence, of written observations. However, the same has been tried to do with Byzantine historiography. And as every Byzantinist knows, we are very poor in this regard with comparison to late medieval England, for instance. Nevertheless, we have this pioneering catalog of descriptions of meteorological phenomena published by Johannes Preiser-Kapeller in 2004 in modern Greek, which somehow limited the accessibility to people outside of Byzantine studies, I would say. You see here one sample entry, so you have a number, you have the year, the dating, you have the type of the phenomenon, and you have the description of the evidence. And then you have these extracts from these various sources describing this phenomenon. So that's a great, it's a treasure really of what Johannes Preiser-Kapeller has provided here. But of course, his idea was never to use this for actual quantifications, because he's very well aware about the shortcomings with regard to density and also the biases we have in all these sources. Nevertheless, the data of Preiser-Kapeller was then turned into an English list only of dates and events, as if these were all evidence of the same kind, and was then used for visualizations like this. At least what you can see here, this is for half centuries and the types of phenomena we have. As expected, we know much more about weather phenomena in and around Constantinople than for other regions of the Byzantine Empire, as is the case for everything else in Byzantine history, more or less. But nevertheless, this was also actually used for quantification, like in this study by John Holden and others published in 2014, where they actually then counted the number of severe winters, the number of droughts, the number of famines mentioned in this catalog of Preiser-Kapeller. And you can see here, actually, if we would follow these quantifications, yes, the 11th century, obviously, we also a peak in the number of calamities. However, as we will see, and this is the next part, of course, the frequency of calamities of portents, which we find described for a specific reign, for a specific ruler, of course, is very much depending on the narrative strategy of the respective historian. So you cannot use this just as data like a modern-day meteorological bulletin. But this, unfortunately, is time and again happening, as we will see. So I come now to this interpretation of historiography, even leading to the notion of a collapse of the Eastern Mediterranean. So I have talked about the history of Leo the Deacon, that he was expecting the end of times for the year 1000. And he was especially writing during the first half of the reign of Basil II. And if you know the first half of the reign of Basil II, it was actually a time where you could expect that things are not going too well. So you have two major uprisings by generals, you have constant civil wars, you have defeats against the Bulgars. So the first half of the reign of Basil II somehow supported this already existing apocalyptic idea of Leo the Deacon. However, he died in the year 1000 and did not experience the second half of the reign of Basil II. And actually, we don't have a contemporaneous history for the second half of the reign of Basil II. What we have then are later historians writing in the late 11th century, after the severe crisis of the empire, especially after the Battle of Manzikert, the almost collapse in the 1070s, then writing under the influence, under the experience of this severe crisis, And for them, Basil II, especially the second half of the reign of Basil II, is the apex of Byzantine, of Roman power. So they have no incentive to describe a lot of portents and catastrophes for the second half, in contrast to Leo the Deacon. The opposite is true then for the successors of Basil II, as we will see, the successors of Basil II, there the pages are full of portents and calamities in order to frame this general impression that there is the beginning and then the peak of this severe crisis of the Roman Empire. So for instance, one of the few references we have in the history of John Skylitzes to one climatic calamity in the second half of the reign of Basil II is for the winter 1010-1011, when there was a severe winter. There was also an earthquake, and this is then interpreted as an omen for a rebellion in southern Italy in the next year. This is all what we learn about such phenomena for the second half of the reign of Basil II. However, we have independent traditions outside of the Byzantine traditions, which very much make clear that actually other things happened, as it had happened in the first half of the reign of Basil II, such as again in the Armenian tradition for the year 1003-4, we have again a certain star, and then we have the outbreak of a severe plague, not only in Armenia, but also in the eastern provinces of Byzantine Asia Minor, including the area around Sebastia, Sivas, which was also a center of Armenian settlement. We have similar descriptions in the Syriac historiography for northern Mesopotamia, for southern Mesopotamia, and also areas across the border in the Byzantine territories. But this is not referred to in the Byzantine sources, writing much later and writing in the different framework for the reign of Basil II. And as I've said, that's then totally different for the successors of Basil II, where then the pages begin to become full of portents and catastrophes. In John Skylitzes' history, for instance, starting with the reign of Romanos III Agyros, and there we have famine and pestilence in Asia Minor in 1032. We have earthquakes. We have another earthquakes. We have a star coming from the south to the north. However, what John Skylitzes is still granting Romanos III Agyros are efforts to dampen the effect of these catastrophes. In this paragraph, and also in the following one, he's referring to actual measures of the emperor to distribute money so that the people could get back to their villages, to invest in the infrastructure of Constantinople, to restore a leper house, so that he's trying to help the people to use the resources of the state to reduce the vulnerability of the people. This is granted by Skylitzes to Romanos III in contrast to the following regency, which starts with, at least in the narrative of John Skylitzes and of others, with the murder of Romanos III Agyros at the instigation of then the villain in the story of John Skylitzes, which is the eunuch John of Phanodrophos. He is behind the murder of Romanos. He is behind the marriage of Empress Sui and his nephew Michael IV, who is then ruling as emperor, although John of Phanodrophos is the power behind the throne. And these pages on the reign of Michael IV, his nephew Michael V, and Jonathan of Phanodrophos are the pages with the highest density of catastrophes and calamities in the entire history of Skylitzes. So there it is fairly clear that this is supporting his framing of this reign, his narrative strategy. And he makes this clear, so from the beginning, it was not pleasing to God, and even the emperor himself is affected by a disease which we now can identify maybe as epilepsy. And if we follow these texts and what Skylitzes is writing, he is using a framework which is very similar with what we find in other historiographic traditions, like in the Chinese ones. There we have this notion of the mandate of heaven, already described in the early Han period, so that heaven is legitimizing the ruler, and heaven is also indicating the legitimation of the ruler with portents and signs, so that wind and rain come at the right time, auspicious stars become visible. Of course, if the legitimation of the ruler is declining, the opposite is the case. So wind and rain come at the wrong time. We have an increase of calamities and of portents. Mark Elvin, in his study on the interpretation of celestial phenomena, has called this a moral meteorology. Again, in the ancient Greek sense, meteora, everything which is in the sky, interpreted in a moralizing framework, so indicating the moral quality of the ruler, the moral quality of the elite, maybe of the people as such, and therefore also then connected to the fate of the dynasty or of the polity at large. And a similar framework of a moralizing meteorology we find in John Skellitzes, and he makes it explicit. He has, for instance, the story of a vision of a servant of the bishop of Pergamon in Asia Minor, who sees a eunuch, of course, it's John of Anatropos, who brings 3 vessels full of vermin and locusts and calamities, that he is really an apocalyptic figure in this description. And it's also clear this came and will come upon you because of your transgression of God's commandments and the desecration of Emperor Romanos, which has taken place in the violation of his marriage bed. So that's clearly a moralizing meteorological framework for the entire amount also of portents and calamities described during this reign. And along similar lines, it's also clear God is not prepared to allow for reducing of the amount of calamities, even if then when during a time of drought, a big procession is organized in Constantinople, and John of Anatropos himself is leading us in this, carrying the mandilion, the holy image brought from Edessa 100 years before to Constantinople, that this is to no avail. And not only did it not rain, but a massive hailstorm was unleashed. So this is how God was signaling what he was thinking about these guys down there. But nevertheless, there's then one sentence which is sometimes overlooked in this high density of calamities. John Skellitzes has to grant that also the regime of John of Anatropos was able to reduce the need of the people in Constantinople by buying grain in Greece. And with this, the citizens were relieved. So this is maybe somehow where also more of the reality is somehow manifesting itself, and we also have other indications that the reign of Michael IV, John of Anatropos, was not that unpopular. But even here in John Skellitzes, we have a small hint. But that's a very short, one could say, when he goes outside of this usual framework. It's then clear later also then, it's then coming towards the peak that God frequently shook the earth. The inhabited world was assailed by an awesome and fearful portents, comets appearing in the sky, storms of wind and rain in the air, eruptions and tremblings on earth. In my opinion, the things presage the forthcoming unparalleled catastrophe for the tyrants. So here we have clearly these moral interpretations of Meteora, and he is, of course, then referring to the eventual downfall of, after the death of Michael IV, his nephew Michael V takes over, but he is then overthrown in a revolution, one could say, in Constantinople, and he, and together with his uncle John of Anatropos, they are blinded then, which is depicted here in this image from the Skellitzes Mathetensis. And of course, that's also more or less the fulfillment of the entire framing of the reign John Skellitzes has provided. So it's very hard. This at the same time makes it complicated to get to the actual amount of catastrophes or calamities which we should expect in the reign, since it's so much embedded in this narrative strategy of Skellitzes. Still, what we have partly this natural scientific data which helps us to reconstruct the actual physical amount of some of these phenomena. And again, we have observations outside of Byzantine historiography, which, for instance, confirmed that there was a famine in the 1030s. Not only in Eastern Asia Minor, but also in Armenia. We have similar descriptions in the Syriac tradition from northern Mesopotamia. So if we have one of these events described in Byzantine historiography, and of course in a specific framing, what these independent observations, independent historiographic traditions can help us to do, if we would like to reconstruct the paleoclimatology of the period, is to triangulate these events. So we have confirmations, yes, there was a famine, and it was not only in the Byzantine provinces, it was also in Armenia, it was in parts of Mesopotamia. So we then have maybe a better estimate. Of course, we also have to take into consideration the individual framing of these historiographies, but still there are somehow independent points of observation. John Skellitzes seems to continue this framing for the reign of Constantine IX Monomachos, where he also says, a comet appeared traveling and it presaged the forthcoming universal disasters, but nevertheless, the density of portents and calamities for the reign of Constantine X is much lower than in the history of Skellitzes. One of the rare significant events is the severe winter of 1048, which contributes to a freezing of the Danube, which allows the Pechenegs to cross over to the Byzantine provinces. Again, for this extreme year of 1048, we have confirmation from other neighboring historiographies. and also all the way to China. The year 1048 is the year of the most dramatic flooding of the Yellow River, which was relocating its entire lower stream over hundreds of kilometers. Hundreds of thousands of people died, millions of people lost their homes, a severe crisis also for the Song dynasty. And this also confirms that this was also one of the peak years of this climate anomaly within this odd solar minimum. So again, we can somehow triangulate the actual manifestation of these climatic fluctuations if we use these various observations. And here I tried to put on a map some of the selected climate anomalies and epidemics which we find described in these overlapping historiographies for the years between 1025 and 1050. And as you can see, there is quite a number of them. And this could actually give you the impression, so maybe they were not wrong to expect the apocalypse. And actually this was one of the most severe periods in the climate and otherwise history of the region. And this is the interpretation which, especially based on historiography, followed Ronnie Ellenblum. He published in 2012 this book on the collapse of the Eastern Mediterranean, which is still often cited and also used even for other interpretations of periodization of Islamic history, for instance. And his argument was that on the basis of all this historiography, we can reconstruct a major climate anomaly in the 11th century, a major crisis, climate-induced crisis of the agrarian empires in Egypt, in Byzantium, in Mesopotamia. And these weakened empires at the same time were attacked by nomadic groups from Central Asia, where a long cold period motivated these groups to invade the southern regions, the Seljuks in the Middle East, the Pechenegs at the Danube. And all of this in combination contributed to a collapse of the societies, a collapse of the classical Islamic period, and that then this region more or less then from then on fell into the long decline, which then would allow barbarians like the Crusaders from the west or the Mongols from the east to conquer this former core, economic core of Western Eurasia. So that's more or less the narrative. And Ellenblum, unfortunately, he died last year, and we had several friendly but heated debates about this. Ellenblum only relied on historiography. He deliberately left out proxy data, natural scientific data, because he argued the temporal resolution and also the spatial resolution of this data is not sufficient to reconstruct the short-term climatic catastrophes he's interested in, and we should only rely on written sources. But one could say he relied to written sources too much. He was more or less including this apocalyptic framing into his interpretation of the period, taking this historiographic data at the one hand at face value, and at the same time only selecting those passages which supported his narrative. And on the other hand, by excluding the proxy data, he also overlooked one essential aspect which has been made for Byzantine economy in the last years, that the period of the 11th, of the 12th century actually was a period in the long term of continued economic agricultural growth, which can be reconstructed on the basis of pollen data, here synthesized by Adam Stepsky and his colleagues. And we see this begins with the stabilization of the Byzantine borders in Asia Minor in the 9th century, in the Southern Balkans in the 10th century, and it continues. Of course, what this data cannot show are short-term, 1 year, 2 year crisis, because the temporal resolution is too low. Here, Ellenblum was right, but still we can see a long-term trend of at least stable agricultural conditions in these provinces. And this is totally lost in the scenario Ellenblum is providing. And at the same time, as I said, he was selecting some pieces of historiography. He was not citing this text, but it would have fitted into his narrative. This is the description of one of the biggest far-reaching raids of the Seljuks already ahead of Manzikert in 1070, when they devastate the city of Konai in already Western Asia Minor, later than the birthplace of the Koniates brothers. And Konai had a center, the shrine of the Archangel Michael, and the inhabitants are able to hide themselves in a canal system nearby, so they can avoid the Seljuk warriors. However, due to an unexpected rainfall, this canal system is flooded and all the refugees die. And this then motivates Ateliates to say not only the enemy, but the very forces of nature seem to be fighting against us. So this somehow seems to confirm again this notion of a climate-induced collapse. So the climate or the forces of nature were behind the crisis of the Byzantine Empire. However, if you follow the narrative of Ataliates and others like Scilicis Continuatis in this period, you can see that after the Battle of Manzikert, where we have the peak of the crisis of the Byzantine Empire, climatic calamities, portents, yes, but climatic calamities don't play a similar prominent role. They are largely absent. What we see in the story of Ataliates, for instance, is the role of the regimes, of the rulers, who, in contrast to earlier rulers, such as Romanos Ageros, for instance, failed to help the people. So it's written, the rulers did not let up on their daily injustices and legal trials, but acted as though the Romans were not being afflicted by anything out of the ordinary. So it's the human inactivity or the wrong human actions which is decisive for the crisis of the empire. And that's also part of the story which is not included in this notion of a collapse of the east of the Mediterranean. That these societies were not only victims, inactive victims, but there were some aspects of dampening the impacts of these calamities, of an embedding of the effects of these calamities within a social framework, which is totally lost if we only look at that side of this catastrophic interpretation, which we find, for instance, in the book of Ellenblum. The same is true for another important showcase in Ellenblum's book. This is the Great Calamity in Fatima, Egypt, where he claims, and also in a posthumously published article a few weeks ago, that more or less the Fatimid regime in Egypt was totally only depending on the Nile flood. So that more or less the sequence of high and low Nile floods was the only factor determining socio-economic dynamics, that they were actually not able to do anything in the face of the failure of the Nile flood, and that climate more or less was determining the fate of Egypt throughout the century. That's very explicit in this text. However, if we look again at the historiography as such, at the interpretation, here al-Maqdisi writing in the 14th century but using earlier material, in the list of his factors for the Great Calamity, it's the weakness of the Caliph's authority, the deterioration of the affairs of the state, usurpation of power by the military commanders, the continuous strife among the Bedouins, the failure of the Nile is only the fifth in the sequence, and the absence of cultivation of the lands that has been irrigated. There's even a later passage where he says, even then when the Nile flood was sufficient again, peasants were not able to cultivate the land because of the lack of stability, the lack of security. So again, it's the social dynamics which are decisive. It's not a lack of precipitation, it's a lack of security. And these aspects are lost if we again only look at the climatic aspect without taking into consideration this large embedding of these calamities. So I come to the conclusion that if we contrast these archives of society and these archives of nature, we have to be aware that between climate and society, disasters should be understood as hybrid socio-natural events. So, of course, there is a sheer physical aspect to it. There is a sheer physical impact. A flood destroys a settlement, infrastructure. A drought is destroying a harvest. That's there, and that's a natural phenomenon which we can reconstruct on the basis of the archives of nature. But there are various aspects how these calamities are then embedded in a social framework. On the one side, as we have seen, social context matters because human actions could affect the intensity and frequency of disasters in both ways. So by dampening the effects, by using infrastructure, by using buffer capacities, for instance, to bring in grain from other regions, but also by increasing the risk for erosion along the Yellow River, as we have seen. And also in the long-term interpretation and framing of the descriptions, also what to make, how to make sense of these events. Also there we have to think about the social framework, and this then determines what we read in our sources. They are not such just data and descriptions of the physical impact, but they are embedded in this framing of these events, often generations or centuries after the events. And therefore, it's not possible just to use them like data, like ice core drillings or other natural scientific data. And the ideal is, of course, of consilience, as it has been called, that the specialist for the natural sciences and the specialists from the humanities meet each other at eye level, bring together the archives, discuss their potentials and pitfalls, becoming aware of the problems. There are also a lot of problems with the natural scientific data with regard to dating and interpretations, to be honest about this, and then to provide more complex, more nuanced descriptions of this interplay between natural dynamics and social dynamics. That's the ideal, and sometimes it's fulfilled. However, what we often see, and this is a publication which came out only a few weeks ago, is that very often it is the scientific perspective, also the scientific publication culture which takes the lead. And then there's again the tendency to aggregate all these individual events, all these individual narratives with their peculiarities in one homogeneous mass of big data, like in this study where all this Chinese evidence is condensed to one timeline of the frequency of wars and the downfall of dynasties. And this quantitative data can then be correlated and adapted to the needs of the archives of nature, to natural scientific data. In this study, it's then correlated with the sequence of short-term climatic anomalies after volcanic eruptions. And there you have a correlation. There you can then claim that volcanic climate impacts can act as ultimate approximate cause of Chinese dynastic collapse. Here the authors were still careful. They say can. Nevertheless, for historians, the more important thing is how. What is the chain of causality? And if in this case, why not in that case? And how did the societies deal with this? How did they interpret? Were they aware that this was a background of the crisis, or how did they interpret the importance of the phenomena they were seeing? These are the things the historians would be more interested, which very much disappear in this condensed amount of big data. But nevertheless, they were still careful. However, what then is the result in the media is something like this. This then makes it into the headlines. Major volcanic eruptions caused Chinese dynasties to collapse. And we are back to climate determinism. Things we had hoped that we had overcome since the 19th century. And I also would guess that this is not helpful in the current debate about climate change. What can we learn from it? So that we are all doomed and we cannot do anything about it? Or should we be more open to the actual complexities, how societies dealt with earlier phenomena, also with regard to the interpretation, what would change within the societies? Would this be more interesting than such assumed one-to-one linear causal links? But nevertheless, that's the issue we are dealing with. Therefore, I'm very much in favor of this initiative started by Dharma de Groot and his co-authors in Nature, so one of the most prominent journals, where they published last year this article about a rigorous understanding of societal response to climate change, where they argued for a history of climate and society, which does not lend itself to simplifying scenarios. And they problematized various aspects we have talked about, like historical climate sources are taken at the face value, which you should never do, ignoring what cannot be quantified, changing climate society pathways ignored, so simplifying linear causalities and selection bias towards crisis and collapse. That's also, we have, it is called in the article, the big collapsology. So climate killed the Roman Empire, climate killed the Mayas. And if you look in detail what is actually happening on the ground, then this is not true in this one-to-one relationship. But still, this is what then often comes out and ends up in the media. And that's a problem. So I come to the end, just news for those who maybe would like to be active in this kind of research themselves. This is just, we agreed upon this yesterday. There will be a special issue of the Spanish journal De Medioevo on the topic of moral meteorologies, to be published in 2024 with the deadline next year in autumn. So you still have enough time if you would like to contribute. I will also then distribute this via various channels, but just to let on this occasion to let you know that there will be also something more along these lines. And with this, I thank you very much for your attention, and maybe we also have some time for discussion.